Hello there, my name is Gregory Carlson, and this is the last part of finding derivatives of functions. So I did a little trick on the last one that I'm going to teach you about in the next video, but let's find the derivative of 2 over t to the 3. Don't get worried that we have a t instead of x, doesn't really matter. We know that the derivative definition is the limit as h goes to 0 of, and in fact, let me write it up here. Our definition of any derivative, and I hope you've memorized this by now. If not, memorize it right now. It's f of x plus h minus f of x over h, the limit as h goes to 0. So that's the definition we're going to work with, so let's apply it. This is going to be 2 over t plus h to the third, okay, because we plugged in t plus h we plugged that in for t, minus g of t, which is 2 over t to the third over h. Okay, so unfortunately this one's going to be kind of a pain, but bear with me, it's going to be okay. So I am going to go ahead and do that trick where I combine these fractions. So this is t plus h to the third over t plus h to the third. And over here I'm going to multiply by t third over t to the third, just like we kind of did before. So now I've got g prime of t equals the limit as h goes to 0 of, I'm going to times it by 1 over h over here, which is my divided by h. And on the top, I'm going to have 2t to the 3 minus 2 times t plus h to the 3. And on the bottom, I have t to the 3 times t plus h to the 3, just like that. Now, don't try to cancel this with this. Hopefully by now you learned you can't do that because of this minus sign right here. So we are in calculus, and this one's a little bit harder, so here's what the next step would be. Let's go ahead and FOIL this out. And so you may need to FOIL that out the long way. I'm going to use the binomial theorem. So that's going to be t to the 3 plus 3t squared h plus 3th squared plus h to the 3. And on the bottom, I still have t to the 3 times t plus h to the 3. Luckily, we're not going to need to worry about foiling this one out, so I'm just going to leave it alone, okay? So I'm going to rewrite this numerator up above. So this numerator is 2t to the 3, and I'm just going to distribute the negative 2, okay? So that'll be negative 2t to the 3 minus 3t squared h. No, that should be a 6. Excuse me, that should be a 6. Sorry about that. Do you see what I'm doing? I'm just doing negative 2 times that, negative 2 times that, which would give me negative 6. So now it's negative 2 times the next term, which will be negative 6th squared minus 2h to the third. So I just rewrote this numerator up above. I see that the 2t to the third and the negative 2t to the third cancel. Say that 3 times fast. So I notice I need to, well, let me just write the next step down. So on the top, I have negative 6t squared h minus 6th squared minus 2h to the 3. On the bottom, I still have all of this. And I'm still timesing by 1 over h. All right, so I hope you followed all of that. If not, leave me a question in the comments. And what we need to do now, the last thing we need to do is cancel this h, because as soon as we get rid of this h, we can evaluate the limit. So if I factor out an h out of the top, I'm going to get the following. The limit as h approaches 0, and that's going to be h times negative 6t squared minus 6th minus 2h squared times 1 over h all over t to the third times t plus h to the 3. Okay? So all I did there was I just factored out an h out of the numerator, out of all three of those. Everything else stayed the same. So h cancels with h, which gives me negative 6t squared minus 6th minus 2h squared over t to the third times t plus h to the 3. Almost there. Now we can take the limit. Now that we got the h out of the bottom, we don't need to worry about 0 divided by 0 or a 0 in the denominator. So now let's evaluate this h. Let h go to 0. This term goes to 0 because h is multiplying. This term goes to 0. And this term goes to 0. Okay? So now our limit is gone, and we get negative 6t squared over t to the third. Okie dokie. So, what's going to happen now is, oops, I'm sorry, I left, okay, I was wondering, oh, where was my mistake? Remember, so we have t to the third, just that h went away. So we still have t to the third, and we have another t to the third, okay? That's why I was confused for a second. We have t to the third, and this is still t to the third right here. So I have t to the third times t to the third. So in fact, this is negative 6t squared over t to the 6, okay? So this t squared cancels with this t to the 6, which gives me negative 6 over t to the 4, because when you cancel 2 on the top and 2 on the bottom, 2 of them cancel, so you get 2 to the 4. So the final derivative, g prime of t, is equal to negative 6 over 2 to the 4. That was a tricky derivative to calculate, and but that's why we're in calculus, is to do these tricky ones. And believe it or not, help is on the way. I have something that I'm going to show you that's going to be able to get us from here to here in about 2 steps instead of 10 steps. But it's still good to know how to do these the long way to make you a rigorous mathematician. I'm going to go ahead and do this last problem in part 5, because this is also a tricky one that has its own strategy. And so I will see you in part 5 of Finding Derivatives. If you found this helpful, please make sure that you like and subscribe. See you in part 5.